Okay, today we will be dealing with difference of two squares. So how are we going to factor difference of two squares? So there are many things that we will have to consider before we're going to factor difference of two squares. First is we're going to tell if the given expression is factorable by difference of two squares. And how are we going to factor if we have identified if that is factorable using difference of two squares? First is this. The first thing we're going to identify or tell that is factorable using difference of two squares is by the word alone 2 and squares. So therefore, the given expression is a binomial. So it means that that is two terms. So we can see here that we have first and the second term, and that is two terms. And second is, if the given expression has two terms, and the first and the last term should have been a perfect square. So what do you mean by perfect square? So it means that if we have numbers that includes 1, 4, 9, 16, 25, and so on. So that means that if you have 1 squared, that is 1, 2 squared, that is 4, 3 squared, that is 9, 4 squared, that is 16, and so on. So those are the numbers that are going to multiply by itself, and the product means that that is a perfect square number. And with regards to our variables, the variable should be a factor of 2. So it will start with 2, 4, 6, 8, and so on. Okay? So here, if we have a squared minus b squared, the formula here can be factored using the product of the sum and difference of two squares. Okay? Thus, the difference of two squares comes from its name, from this one, and the factored form is the product of the sum and difference of two terms. Okay? So, I have here an example. What if we're going to factor x squared minus 4y squared? Okay? So again, we're going to tell if the given expression has two terms. So we have two terms. First and the second term. So we have two terms here. Now, is the first term a perfect square? Though that is only a variable, the exponent is 2, that is x squared. Therefore, we can say that that is a perfect square term. How about this one here? We have 4. Yes, 4 is a perfect square that is obtained by multiplying. Yes, multiplying 2 by itself. And y squared is multiplying y by itself. Before I forget, let me go back to the characteristic of difference of two squares. The word here is difference. So therefore, that should always be subtraction. It can never be addition, or it can never be positive. That is always negative. So therefore, since this is factorable using difference of two squares, what we're going to do now is we will have two factors, and that factor is always the product of the sum and difference of two terms. Again, okay? The factor form of the difference of two squares is always the product, because we're going to multiply the two terms, or the two expression, the two binomials, that is the product of the sum and difference of our terms. Okay? So what we're going to do here is simply just get the square root of this one and get the square root of this one, and those are our factors. So what is the square root of x squared? Or simply just think of a way that we're going to divide or put the expression x squared into half. Okay, so that means x squared, expand that one, and we will have x times x is equals to x squared. How about 4? What is the square root of 4? So the square root of 4 is, obviously, it is 2. And 4 is obtained by multiplying 2 by itself. That is 2 times 2 is equals to 4. And just expand 4. So this 2 times 2. And our y squared is also the same what we did in our x squared. Just expand our y squared, and that becomes y times y, and thus our factor of our x squared minus 4 y squared is equals to x plus 2y times x minus 2y. Okay, how about this one? X squared minus y squared. So if you can see that this expression here is just the same to our formula. What they differ is only for the variables a and b, x and y. But in our expression here, that is that is on our exponent, we have squared, 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 squared. So just simply copy our formula, x, yes, the product of the sum and difference of two terms. So this is the product of the sum and difference of our x and y. Okay? So how about this one? X squared minus 121 y squared. So again, in factoring, all you have to do is just expand it directly. So that becomes the product of the sum and difference of our two factors. Okay? So we have here x squared. Just expand your x squared. That is x times x. And our 121. So what is that number that is multiplied by itself and the product is 121? Yes, that is 11. So we have here 11 and 11. And for our y squared, that is y and y. As simple as that. Okay? So how about if I'm going to give you a problem like this? Okay, I'm going to give you, just pause the video and give yourself 1 minute to solve. Pause. Okay, so after 1 minute, let us try to solve for this one. If your answer is the same with my answer. So again, this problem is difference 25 and 144. So what are those numbers that is multiplied by itself that the product is 25 and 144? How about for 25? Yes, it's 5. How about for 144? 12. Very good. And for our x squared is simply x. Okay, so let's factor this one. Difference of two squares using the product of the sum and difference. So your 25 is 5 and we have our x. So it is simply as x, and here is 5x, and for our 144 is 12. Okay, so we have here 12 and 12, and thus that is our answer. So as simple as that, that is very easy. So you can do that for yourself. So if you want to be clarified again, just comment below, and I'm going to answer your queries if I have time. Okay, so again, if you want to be clarified again, just rewatch the video and do all the problems, solve it yourself, and compare our answers. Okay?